Crash Course Instrumentation, Diagnostics, Episode 3. Divide and Conquer, Narrowing Down Faults, Fast. Welcome back to Crash Course Diagnostics. In our last episode, we looked at how opens, shorts, and voltage behavior can confuse new techs, especially when the meter seems to contradict reality. Today, we're showing you a powerful troubleshooting strategy that experienced techs use all the time. Divide and conquer. This simple mindset can save hours of testing, reduce frustration, and help you think like a diagnostician instead of a guesser. Let's break it down. What does divide and conquer mean? It means taking a complex problem and splitting it into smaller, more manageable parts. You don't test everything. You pick a spot in the middle of the circuit and test there first. Think of it like debugging a mile of wire. Instead of checking every inch, you go halfway. If the signal's still good, the problem must be downstream. If it's not, it's upstream. This technique works with voltage tests, continuity checks, pressure gauges, even software logs. Anything where there's a measurable state that helps you isolate the fault. The goal is to cut the problem space in half with every test, like binary search in computing. And before you even grab your meter, take a minute to plan your approach. Ask, what result am I expecting to see? What would a good reading look like? What would a fault reading look like? This mental planning step separates the diagnosticians from the button pushers. Historical spotlight. The logic tree method. During World War II, radar systems were prone to mysterious failures. British technicians working under pressure developed what we now call the logic tree method, a structured form of divide and conquer. They treated every system as a tree of possible failures, and each test would eliminate half the branches. This method was so effective it became the basis of military electronics maintenance and is still taught in avionics today. So when you use divide and conquer, you're using a technique refined under battlefield pressure. Conclusive versus inconclusive tests. A smart test tells you something definite. A weak test just adds confusion. A conclusive test might say, the voltage is good here, so the problem is further down. An inconclusive test might say, I don't really know what this means. Before you move a probe, ask yourself, what answer am I hoping to get from this test? Will it eliminate possibilities? Will it isolate a fault? If not, pick a better spot to test. Real world. Case, dead lamp circuit. Let's say you're called to troubleshoot a simple lamp that won't turn on. The circuit includes a power source, a switch, a lamp, wiring. Step 1. Check the supply voltage. If there's no power to the circuit, everything else is irrelevant. Step 2, you check voltage at the lamp. It's 0. Step 3, check voltage at the switch output. Still 0. Step 4, check voltage before the switch, and boom, it's 120 V. You've just isolated the problem to the switch. Only a few smart tests, and you didn't waste time opening junction boxes or replacing the bulb. That's divide and conquer in action. Final tip. Document as you go, write down your findings. If it's a complex system, build a fault table. Record what you tested, what result you got, and what you ruled out. It not only helps you diagnose faster, it helps the next tech pick up where you left off. And if you're wrong, you have a map that shows where your logic went off track. Coming up next, in the next episode, we'll explore real fault combinations that can trip up even seasoned techs, and how to think clearly when there might be more than one thing wrong. Until then, don't just guess. Divide and conquer. Like, share, and subscribe for more episodes from Crash Course Diagnostics. Big thanks to Tony Kuphaldt and the open source community for making this series possible. See you Sunday.